I've created a simple console application named Polymorphism to illustrate how this works. The idea here is that we're going to have two classes. Let's scroll down past some of this, we'll come back. The first is an employee class, which will act as the base class. Employee has three member variables: name, which is a string, bonus level, which is an integer, and profit, which is initialized to 0. And in the employee constructor, you pass in the name and the bonus level, and we set them accordingly. And of course, profit's already been initialized. Employee has a virtual method, marked with the keyword virtual, named PlanBizTrip. And when an employee plans a business trip, he creates a travel agent object, which we'll look at in a moment, and tells it to book a flight, passing in the flight type of coach and the name of the person. Now, what we're looking at here is coach is an enumeration value within the enumeration flight type, which is within the travel agent class. When we look at travel agent class, we'll see that there's an enumeration flight type, and one of the enumerated values is coach. So we're going to pass in coach and pass in the employee's name. We've got a second virtual method, also with the keyword virtual, called takeProfits. When an employee takes profits at the end of the year, the profit is set to the bonus level times 500, and we add that to whatever the current profit is, and then we just write it out. Now here's our derived class, manager, which derives from employee, and here's that colon indicating that manager derives from employee. Managers add their own member variable, manager level, and they default to 1, so we initialize that value to 1. Here's the manager constructor. It gets the name and bonus level just like an employee does, but it also gets a manager level. Here's the colon for chaining up to the base class, and sure enough, we invoke base and pass in the two parameters that employee expects, and now we take the manager level and set the manager's manager level member variable to the manager level that's passed in. We're now ready to override the business trip method. Here's PlanBizTrip, which is the same exact method with the same return type as in the employee. And the signature must agree, that is, it must have the same number of parameters, in this case, none. Here's the keyword override, indicating that we're intentionally overriding this method in the derived class. And why do we override it? Because when a manager plans a business trip, he does something slightly different. He also creates a travel agent, but what he passes in is not coach, but rather first class, because managers in this company fly first class. Similarly, we have a takeProfits method that is an override of the takeProfits method in employee. But when a manager takes profits, they multiply the manager level times 750 and add that to the profit level. And then they call the base takeProfits method explicitly, which will add to their profit the same way that any employee does, which is to multiply the bonus level times 500. So managers do quite well when they take profits. Let's take a moment before we run this to look at that agent class. Here's our class travel agent, and within that class we declare the enumeration flight type and the three enumerated values, coach, business class, and first class. When you invoke the book flight method, you pass in one of those enumerated types, and you pass in the name of the employee. We then create an output string, and we switch on the type that was passed in. If the type is coach, we add the word coach. If it was business class, we add business class, and if it was first class, we add first class. All of this stands in for the work that would actually be done of booking a real flight. And we now are able to say, Joe will be flying first class. Let's run this and see what happens. Okay, Fred, our first employee, will be flying coach, and his profit this year will be $1,000. Joe will be flying first class. His profit this year will be $5,250. Let's go look at Maine and see how Fred and Joe were declared, because that's a very interesting piece of information. Here we are in our tester class with Maine. We declare two employee references. Employee 1 is assigned a reference to the employee, Fred, which we instantiate by saying new employee Fred. Here we instantiate a new manager, Joe, but we assign the results not to a manager instance, but to an employee instance. That is, we want to treat these employees polymorphically. Down here, we call takeProfits and PlanBizTrips on takeProfits on these employee objects. Notice they're both employees. And the right thing happens. For the one that's really an underlying employee object, the employee method is called. For the one that's really a manager object, the manager objects are called. Virtual functions are the mechanism that implement polymorphism and make the magic work. It's virtual functions and overriding virtual functions that allow you to treat all employees as if they're simply employee objects, whether they happen to be managers or other derived types of employee. As a client, all you need know is you have employee objects, and you can tell them to book flights or to take profit. And if they're a manager, the right method will be called. And if they're another kind of derived class, the right method will be called. And that's a very, very powerful mechanism in object-oriented programming.